So continuing on our problems of applying u-substitution to solve integrals. So we're going to increase, as I said, the intensity of our difficulties of this integrals of functions. And we will be also using some functions which are rational functions and functions which are trigonometric also. So let's start with the first one. So we have a rational function where it's a cubic function divided by 2 plus x4 to the square. So in these kind of problems, we have to think what would be the u-substitution. So once again, this x cubed on its own is a very simple one. But if you look at the denominator of this rational function, this is a function inside a function. So here, notice that 2 plus x4 is the inside function raised to the power square. These kind of problems, yes, we can apply again our u-substitution. And notice when you take the differentials, now if you started to notice a pattern that if you take the inside function and you take its differential, it is somehow present in the other part of the function. So if you have an x4, taking the differential is 4x cubed, but you have an x cubed present. And that's one way of looking at it. Oh yes, it's going to work. Okay, so hopefully you have done these problems so many times, you can start recognizing patterns. Okay, so let's start with this one here. My u is 2 plus x to the power 4, and my du is now 4x cubed dx. So clearly x cubed dx is here, which is equal to du over 4x cubed dx. Now once we have written down our u's and our du's, after that we just go to the original problem and replace all those functions with that with u's and du's. Okay, so going back to the original problem, I can write this as integral x cubed over dx, remember, is now du over 4, and this 2 plus x4, which is basically 1 over u square. So if I rewrite this, this is 1/4 can come out, and u to the power negative 2 du. Now you know how to do the integral for these functions. It's 1 over 4. U minus 2 plus 1 is minus 1 over minus 1. So our final answer is minus u. Replace the u by the original substitution, which was 2 plus x 4. Okay, need to write it much more better, which is equal to, so this minus I'm taking on the top, u replacing by 2 plus x to the power 4, and this raised to the power negative 1 over 4. Remember, it's an indefinite integral. We put plus c. So that's our answer. Okay, going on to the next problem. Again, it's a rational function. We have a squaring function on the top and a cubic function raised to the power 5 in the denominator. So if you start to see the patterns, the function which is in the denominator, which is the inside specifically, if I take, it's a cubic function, and if I take a cubic function's differential, that's going to be a squaring function. And the squaring function and the cubic function both are present. So our life is very simple here now. So we know what to take the u to be. U would be now 5 minus 3x cubed. Du is going to be 9 minus 9x squared dx. Now remember, we have 4x squared dx. That's okay. We can multiply. You can take, this can also be, you can take the 4 outside. So it's x squared dx. I can write as du over negative 9 equals x squared dx. You should be more concerned, guys, in these kind of problems with the variables. The constants you can manipulate. Okay, so now this original problem, see how I'm going to do little things over here. So the first thing is it's 4. I can take the 4 outside. And then I write this as x squared dx over 5 minus 3x cubed to the power 5. Nice little function I have now. 4. Now x squared dx is du over minus 9. And 5 minus x cubed is 1 over u to the power 5 du over negative 9. Now you just need to have the variables inside, and the rest, the constants, we can take it out. So it's 4 over negative 9. Now take the u on the top. The power of 5 becomes now negative 5 on the top du. So now when we solve it, we are going to have equal to, I'm going to take a little different color so I can see green here. So this is going to be equal to 4 over negative 9 u minus 4 over minus 4. So the final answer is minus times it's 4 over or 1 over 9. Remember, minus with the minus cancel out, 4 with the 4 cancel out. U is going to be replaced by 5 minus 3x cubed to the power minus 4 plus c. So these were rational functions with nice little polynomials present. Let's look at a problem where we again have a rational function, but no polynomials, but some radical roots. How do we solve those problems? In a similar fashion as we did earlier. So the only thing is we'll have radical roots, but look at the inside and the outside. So notice the inside of this radical root is a fourth degree polynomial. And a fourth degree polynomial, when you take the differential, is a cubic polynomial. It's a cubic. And then, so that means these will work. So I know what my u should be. My u should be 1 plus x to the fourth. And du is going to be 4x cubed dx. Notice x cubed dx is here, so we can write this as du over 4 x cubed dx. And now we just go ahead and change the variables. So this is x cubed dx is what? Du over 4. And the rest of the term is 1 over 1 square root of 1 over x4, which is square root of u. Now, make our life simple. Take the 1/4 out. U to the power now minus half du, which is going to be what? Solving this integral, it's going to be u to the power minus half plus 1 is 1/2 divided by half. So what we get, this 2 and 4 cancel out. So we would have a half. And now u would be, okay, let's u to the power half. Final answer is u will be now 1 plus x to the fourth to the power half divided by 2 plus c. So these were all polynomials. We had integrals of polynomials and radical roots and stuff. So now we're going to look at trigonometric functions and how do we solve these integrals. Now keep in mind, whenever you have a trigonometric function, how will you know where it's going to be a u? The simplest rule is, when you're doing these problems, remember the functions. We know that integral of sine x dx is a simple negative cosine x. Integrals of cosine x dx equals sine x. The most important key which you have to remember is, when you're taking integrals of trigonometric functions, this the function which is next to the sine, the argument which we call, it is always an x with the power 1 and coefficient 1. That is the key. Okay, let me write it down very clearly here. It says sine x. Notice the power is 1, the coefficient is 1 in front of x, which is the argument to the sine function dx. And that is the classic hint. When you look at an integral where you see that the argument to the trigonometric function has either a power different than 1 or the coefficient different than 1, automatically know, oh, there is where my u will go. I will have u-substitution. That is the key. So over here, clearly notice, once again, I'm going to repeat that the cosine, which is next to a function inside, is having a coefficient of x to be different than the one. That is a quick sign. There is u substitution, and that is going to be my u. Okay, so keep that things in mind. So I'm going to say u is my 7x, du is 7 dx, and du over 7 is dx. Now when I make the changes to the original problem, see how it looks like. This is now cosine u. Now remember 7x is u. Dx is what? Du over 7. So if we take the constant out, which is 1 over 7, integral cosine u du. Very similar to the formulas we know. So integral of cosine x dx is the same as integral of cosine u du, which is now equal to 1 over 7 sine u. Now remember, your original problem was having variable x. This is the problem which has, this answer, has a variable which is u. So the final answer, you have to change the u to the x's. So it will be now 1 over 7 sine of 7x plus c. Okay? And I know I have forgotten to mention it, but I'm going to say it here now, that when you get your answer and you realize, oh, am I getting it the right or the wrong? What you need to do is you get the final answer, take the differential of this. When you take the differential of this, you should get the integrand part of the integral. So if I take the differential of 1 over 7 sine 7x, what am I going to get? Let me just do a little check here for you. So the check. So the differential of this function, in other words, d dx of 1 over 7 sine of 7x plus c. So what's this equal to, guys? This is equal to 1 over 7. Now we're going to apply the chain rule here. Cosine of 7x, remember cosine is the outside, inside is this, times 7, differential of 7x, and a differential of constant is 0. So the answer is cosine 7x. And that's exactly the integrand we have over here. So every time you're doing a problem, check your answers. Okay. Now let's come over here and look at more integral functions of trigonometric sense. Now we have integral of 2x sine x squared dx. So when you look at this one, you say, oh, sine has an argument which is a quadratic function. And we all know that the formula is sine x dx. Coefficient 1 power 1, which we know is minus cosine x. So that is a giveaway. This is going to be the u. Okay, u is x squared, then du is 2x dx. And that's exactly what we have. 2x dx is du. So when we make the changes, this is now sine x squared would be now what? Cosine u du. Sorry, it should be sine. I ended up thinking of the answer in my head. Okay, sine u. Now, integral of sine u is negative cosine u. Remember, you have to change your u. It is minus cosine x squared plus c. Once again, if you take the differential of this function, so this is a final answer. If I take the differential of this, I should get 2x sine x squared. And that is the right answer here. So let me just do one more checking for you to show. So this check, d dx of minus cosine x squared plus c. So we all know this is negative sine x squared, because when you take the differential, you start with the outside, remember, times the differential of the inside, which is 2x. Differential of constant is 0. And remember, there is a minus already outside. Differential of cosine is a negative sign, so this becomes positive. And that's exactly the expression we have over inside. which is this. Okay, now let's look at a little difficult problem here. So we have cosine of square root of x over square root of x. Now look at this one, cosine of square root. So whenever you have a trigonometric function where you see the cosine or a sine or a tangent, any functions which have a different argument, which doesn't look like the normal way we are looking at, that means, oh, that here in a cosine environment, cosine x dx is sine x, remember. This root x is the giveaway. Oh, that's going to be my u. Keep that in mind. So here's it. My u is square root x, or x to the power half. So what is my du? You take the differential. It's going to be 1 over 2 x to the power half minus 1 minus half dx. I can write this as 1 over 2 square root x in over 1 over 2 square root x dx. So we are given the expression has square root x dx. Now that will become actually 2 times du equals dx over square root x. So now this original problem, guys, equals, so cosine of this would become what? Cosine u times 2 du. Now 2 is a constant, pull that out of the integral sign, cosine u du. Now integral of cosine is a sine, we know that. 2 sine u. Remember the original problem was in the variable x. So what are you going to have? 2 sine square root of x. Final answer plus c. And definitely you can check this answer. Okay. So we have done a lot of these trig and rational functions kind of problems. And now I would like you guys to practice these at least 4 problems, which will help you get comfortable with the topic. Thank you.